Hi, we are going to see a very important critical parameter of a network which is called noise figure, and we will see first the definition. It is defined by a scientist called Harold Frisch. He defined the network noise figure as the ratio of SNR at the input side and SNR at the output side. You know what is SNR, signal to noise ratio. This diagram illustrates a perfect definition of a signal to noise ratio. This is a two-port network. This is at SNR at the input side and SNR at the output side. So what is the noise factor? It is the ratio of input SNR by output SNR. And the noise factor, as I said, is a very critical parameter. It defines how the network is degraded by the signal to noise ratio parameter. So when the lower the value of the noise factor, the better will be the network. So noise factor must be very low as possible for a good network. So generally the noise factor is equal to 1 for a noiseless network, but since the noiseless network is not possible, practically the F is always greater than 1. So when you want to know the noise factor in terms of a decibel, that becomes noise figure, which is labeled as NF, noise figure, and F is noise factor. So noise figure is nothing but decibel value of a noise factor. So NF is also given by input SNR in terms of dB minus output SNR in terms of dB. The diagram, the graph shows a perfect illustration of noise figure. So this value from the peak to this is SNR at the input side, and from this peak to this SNR at the output side. So when I see this is SNR at the input side is 40 dB, 60 minus 100, and SNR at the output side is 30 dB, that is 40 minus 70 gives me 30. So what is noise figure? Input by output SNR. So 40 by 30 the output 40 minus 30 the output of noise figure is 10 decibels. Yes, next is the noise figure for the active elements. Take an example like transistor, diode. So what is the noise figure calculation in that case? So for the active elements, the power gain is of course which is greater than equal to 1. So take a very simple active element. The active element can be anything. So the active element has a gain of G and the input SNR, and this is the output SNR. So as F is equal to Sn by Nn multiplied by S out by N out. So what is S out from this? If I cross multiply, S out is G into Sn. Yes. So what is F? N out by G into Nn, which is the cross multiplication. So if I replace the diagram using the above equation, again the gain is almost the same. So what is NE? NE is nothing but the noise, the extra noise which is added due to the active elements like transistors, diodes, etc. So this is the input noise which is caused by the system. So what is the output noise? The G multiplied by Nn plus Ne. So yes, so F can be written as you know that it is already N out is by G into Nn. So just substitute what is N out, G into Nn by Ne, just substitute and you rearrange it, you give finally arrive at the result of Ne, the noise due to the active elements of nothing but F minus 1, noise figure minus 1 into the input noise. Yes. So when I take a cascaded network, what is the use of, we don't have one single element in case of practical applications. We are going to cascade it with the active and passive elements. In such a cases, how to calculate a noise figure. And again, consider this. So I have 3 elements, 1, 2 and 3, and each and every element has the gain of G1, G2 and G3, and the noise figure of the first element is F1, second element is F2, and third element is N3. Sorry. In that case, as we calculated for a single element, Again I write what is Ne, f minus 1 into Nn, but for the first element it is f1 minus 1 into Nn. So as usual, and use the recursive formula, what is N out? G into Nn plus Ne, but what is the N out here? G3 into Nn3 plus Ne3. So just use a recursive addition, recursive multiplication. The final answer N out is equal to the recursive multiplications and manipulations. So finally I found what is the system noise, N out by G into Nn. So I have calculated what is my N out. So substitute here, in substitute, and finally you get the answer like this. F of system figure, noise factor of a system is equal to F1 plus F2 minus 1 by G1, F3 minus 1 by G2, and follows after that. Now assume your input noise is very equivalent to your active power noise. Then system noise figure is equal to F1 plus F2 minus 1 by G1, and it goes off. So this is for the Young's element in a cascade system. And this equation is called the Friis formula, since it is devised by a mathematician called Friis.